Hi, Assalamualaikum and selamat sejahtera. Today I would like to present about characterize welding signal to weld condition for friction stir welding. And before we start, I am Ahmad Akabi Ahmad Suhaimi. My matric number is B0518100028 and I'm from class 4 BMFG 1/1. And this project is supervised by Dr. Muhammad Kamil bin Sued. So on the overview, I have the project background, that basically the introduction of this project. Next, I have the problem statement, and this is about the problem that I encounter while doing this project. Next, I have the objective of the project. Next is scope project, and this scope that I have to make to complete the project. Furthermore is methodology, and this is about the method that we use in this project. Moreover, it's about the flowchart that make the project to complete. And next, I will explain about fast Fourier transform or FFT and statically analysis can characterize the signal welding. And last but not least, I have the instrument, recommendation, and also the conclusion. So on the project background, I have FSW is about a joining process which pin to rotate against seams between two stationary parts. And there are three levels online internal control that accumulate by the industry. And next, I'll be able to characterize its signal in friction stir welding. And last but not least, the relationship to verify physics process occurring within the welding process. In this new age, all humans use automation devices to make a better life. In FSW, also can be automated process using MATLAB to analyze its signal data that I get from the experiment. In this project statement, I want to make a smooth process of FSW using FFT in MATLAB. I want to able to characterize its signal that I collect in FSW. And lastly, I will able to detect the error from the welding error. The target I want to achieve in this project is to collect welding signal of current, temperature, and vibration. I also want to characterize the signal based on friction stir welding signal. And lastly, to make a process using MATLAB to detect on the welding or plating. The scope in this project is to collect all the database on friction stir welding. I also want to make sure there is no defect along welding process. And lastly, I want to characterize the process using FFT in MATLAB. So in methodology, these are the step-by-step that I have to accomplish to make sure the project successful. We will start with set objective and clarify scope of the project, data collection on FSW, then we go through the MATLAB, and lastly, success on make it automation process. If no, we go back to the MATLAB, and if my data success, maybe it can be used in the future reference in FSW. If not, I'll need to adjust the coding in the MATLAB. So the parameter that I will use in this project is plate with dimension of width 140 mm and length is 120 mm. Every dish will have a defect of 1 millimeter, 3 millimeter, and lastly 6 millimeter. This welding process using CNC 3-axis milling machine with 2000 RPM, and the two material that used in this project is H13 steel. The device that I used to collect the data in this experiment is Pico Data Logger Thermocouple Type K for temperature, Unity UT232 Digital Power Clamp for electric, and lastly Unity UT315 Digital Vibration Tester for vibration. So in MATLAB, I'll be using fast Fourier transform or FFT to analyze the signal. So the analysis is based on magnitude versus normalizing frequency. The smallest value is negative 23 dB for 3 mm and negative 3 dB for 6 mm. Using FFT, I can normalize frequency to 59 dB. This method can identify the type of error FSW through current data. It also can minimize the usage of current in FSW. Normalization is needed to perform increased artifact neural network or ANN performance. And lastly, this study can be evaluated as first step to determine and classification of welding problem. FFT transforms signals from time domain to frequency domain, and this graph is based on time per minute versus frequency hertz. Real welding current signal recorded in the digital form were transformed from the time domain into the frequency domain using the algorithm of FFT. By using the FFT, it can smooth the graph from too many peaks to one loop. As you can see from the graph, the 3 mm defect at 2 Hz to 4 Hz has too many peaks. And by using FFT analysis, it can minimize it to one extreme. And as each welding power source has its characterized spectrum signature, and it is possible to try to identify the type of source based on the frequency spectra. This would, however, require a further research. So this slide is statically analysis is based on temperature analysis. For the defect 1 mm, all the data average temperature is 101 degrees Celsius. And from the standard deviation, the data is clustered around the mean. And there is 4.479 standard error from the data. And from this analysis, we can see the higher heat point is 348 degrees Celsius. So for the 3 mm defect, you can analyze the average temperature is 147 degrees Celsius and the standard deviation 22.942. The data is clustered around the mean, and there is 6.379 standard error from the data. And from this analysis, we can see the higher heat point is 496 degrees Celsius. And lastly is defect 6 mm. The average data for this defect is 160 degrees Celsius. The standard deviation is 35.135. The data is scattered around the mid. And there is 7.049 standard error from the data. And from this analysis, you can see the higher point is 438 degrees Celsius. And by using statically analysis, it shows uncover pattern and threads for the temperature data. And from all the defect data, the peak is 100 degrees Celsius to 160 degrees Celsius. And for the 6 mm defect, the FSW is not fully cover the faulty because of not enough power to fulfill the deficiency. So for the recommendation, to make sure the data that I make is to be used in the future. With my data, it can make less error in FSW. And lastly, to make sure this project can be used in the industry for the automation process of FSW. So for the conclusion, I'll be able to collect all the objective data that I made earlier. So the first point is FFT can make improve in the welding. And next is know that the more minimal peak in the graph is the better in the welding. And lastly, I'll be able to characterize each signal in FSW. So that's all from my presentation, and I do appreciate for your time listening my presentation. Thank you and have a nice day. Bye bye.